Hi, Geo 131. I am so sorry that this video giving directions to this plate tectonics lab is so late. Part of it is honestly that I was unsure how to give useful directions for the map portion. Those of you who have attempted to work with the maps, um, I know that the maps are not ideal. The maps are not great. So we're going to walk through the exercise together. Um, I'm going to say that exercise one is very straightforward and is something that's really similar to what we do in class. And then exercise two, I'm going to tell you to try your best. Okay, that's how this is going to be graded, is by your best. So let's go ahead, share our screen, walk through it. So we've got our experimental overview and some of the science interactive supported materials. Um, you are expected to have a dry erase marker. Um, do the best you can. If regular markers should work pretty well for this as well. So if you don't have dry erase, just an ordinary children's marker, but dry erase markers are available at places like a dollar store. So exercise one, this is very similar to something we do in class. We use cookies and frosting. They're using transparency sheets and clay. So we've got transparency sheet. Now in your lab, they're going to give you one sheet. You're going to cut it in two. I'm just using two sheets right here. And we're going to take, it's pretty straightforward. You're going to be modeling plate motions with your transparency tape or with your transparency and your dough, and you're going to squish it together and move it apart. So let me go ahead and show you. It's exactly as straightforward as it sounds. You're just making a 3D model of this. So I'm going to scooch back my page over here so you can see it and take, I'm a little hunched over. Take a little of the clay. Yours is Play-Doh. Mine is modeling dough, so it doesn't behave quite as well. Squish it out into a nice little flat thing. I do recommend you pre-squish it a little bit, make a little flat, and then see how my transparency is overlapped? Squish it across your overlap like that. And try to get it to stick to your transparency as best as you can. So like really pushing it down because that's going to help. Because really, and this is an answer to one of the questions in here, the clay is your lithosphere. The transparency is basically your asthenosphere. It's what the plate. So your plate is made out of the clay, and then your transparency is the mantle that's moving underneath the clay. So as you pull, and you may want to hold on to it, and it's starting to rip and get thinner. And oh, look, that's a divergent plate boundary. See how it's gotten thinner and it's been ripped? I just showed you how to do the first one. Once again, very straightforward. This is not the part I'm worried about. I'm pretty sure most of you have gotten this that have tried it or attempted it. Let's try the next exercise, exercise two. So I know it's imperfect, so don't let it stress you out. That's the number one most important thing. Try your best. I'm going to give what I've decided is if you clearly have attempted this, you will get the points. Okay? So you're going to look at map one. You're going to start with map one to look for patterns of locations in the earthquakes in the world. So this is map one here. You're going to put your transparency over it and and hold it in place with a paper clip weight I don't know why they say paperclip. You could print it and trace it, but it doesn't say to print it. So you can put it on the computer, like I could take a transparency sheet and trace it like that. That's another way to do it. You can also just, another way to do it, and then I will totally accept, is just print this map, like print them all. If you're at the college, you can print them all and then just sketch it in on the printed version and don't even mess with the transparency. Just take pictures of what you colored in there. So then you're going to look at this map. This map is hard partially because it's the wrong way around. I would recommend saving your image, save. I'm going to go to that folder. And then opening this up. Ooh, opening this up. And rotating it. So if you're going to just go ahead and use the map on the screen, that's one way to go about it. The other way to go about it is you can print it off. That's another way to go about it. You can print free printing at the library. And then you could lay your transparency on top of that and trace it. Or you can just eyeball it. So let's, why did I close that? I don't know. So once it's turned, just so a couple of people said, hey, what am I actually looking at here? So the youngest, this is the age. The redder it is, the younger it is. So notice that like there's a stretch of really young oceanic plate running down the center of the Atlantic Ocean. That is the mid-ocean ridge. Then there's ones extending from the southern tip of Saudi Arabia down to the middle of the Indian Ocean, and then going down in this direction, in this direction. That's another mid-ocean ridge right there. So that's what you're basically adding in. You could also just look at a map of mid-ocean ridges. That might also help. Um, So you're going to examine map 3 to identify areas of highest elevation and infer where the plate boundaries are located around these features. So once again, the map's in the wrong orientation. Open that up. So there's no key here is part of the issue. Dark brown is mountain. So these are the Himalayas over here. And these are the Andes in here. Just focus on the darkest brown. Focus on the darkest brown running through here. Here we have the Alps. Okay. So running through here, we have a whole mountain belt region. So just focus on the darkest brown areas and try to, and once again, I know how imperfect this is. I know that it sucks. I know that this genuinely sucks. This is not, this is really in many ways, not an acceptable, I lost my Zoom screen, not acceptable. Um, I mean, you paid well, you didn't. If you paid, you should get your money back because it's part of the Boomer bundle. But somebody paid $360 for this. So, which is a lot for something that just does not work. So, and then you're going to take your photo of map 1 with the completed transparency paper and upload it to images. when it says here, infer, so let's keep going. Based on locations of the green lines and the blue lines, to draw where you think the major plate boundaries are located on the transparency map. Really, really just give me where you have green lines and blue lines, and that's fine. Like show me where the crust is and show me where the highest mountains are, and that should approximate the plate boundary lines for most part. Take a photo of your completed exercise, and then down here they give you an actual plate boundary. You can use that to help guide you. Um, this is not a perfect lab. I would say exercise one works great. Exercise one, just make sure you squish it skinny enough, really push it down on your transparency paper so it's like a little bit stuck. It's going to work great. Exercise one works great. Exercise two is just try your best. I will grade based on earnest attempt. So don't let it stress you out. Just know that mountains are convergent plate boundaries and mid-ocean ridges are divergent plate boundaries. And if you get that much out of that exercise, that's great. Don't let it take up a whole bunch of your time. And if you want to print the map and color in on that map, that's fine. That's fine. Let me know if you have any questions. I'm sorry, this is less than perfect. I'm working on an alternate solution at all times, but we're going to have to just kind of sally forth this semester. So I appreciate, thank you for being my student, and I hope you have a great rest of your day, and don't be afraid to email me with questions.